Welcome to GDP's Game Algorithms and Gems 2020. My name is Felipe Bellini and this is a video demonstration for the winter midterm. Game Algorithms and Gems is under the supervision of Daniel Macklin at Fanshawe College. The winter midterm is about multi-threading and locks for data protection. In this project, we should see a dynamically generated maze that a few entities will interact with. Each entity has its own thread that handles movement, orientation, and pathfinding. So here in our solution, we have a couple of projects that are of interest. The game project, core, and interfaces. In the game, we should find all the logic for the creation of the threads and the overall behavior of the characters. And the interfaces and the core will contain a couple of classes. In physics also, will contain a couple of classes that are using locks, mutexes to protect data. So back here to our game system scene, we have a couple of defines at the top of the page. These are used to configure the size of the maze and also the amount of characters that will be displayed on screen. So let's run this and check out the final result. I'm using a count of 5 for performance. In the video it will appear a little bit choppy, but the characters are moving. They are trying to dislocate through the maze. And each of these characters has its own thread. I'm going to close and show a little bit of the code. So back again at the code, there's a summary of the methods here in this initialize gems exam. Basically what we do here is that we take the base objects that will be used in the game. I create the maze mesh using this fancy block, which effectively takes the positions from the maze generator, the maze maker, and then I clone this fancy block multiple times and apply that to the points where the maze is supposed to be. Then I create a bunch of colors that are to be used with the characters. Then I create the characters also in the same manner that I build the walls by cloning. Then place the characters into a random and not occupied spot in the maze. Then I create the threads, which is one thread per character. This for every character in the game. I create one thread, which is this function here, create movement thread function, character movement thread function. This thread basically will run while the kill threads flag is down. And what it will do is that it will find a place to move to. Then if a place is found, if a point is found, then we will orient to that point, and then we will seek towards it, and then I will apply the transformations. Like this is basically an integration step inside the thread to show the concurrency. And if you go into these methods here, you can see that I'm applying changes to the rigid body to simulate a physics kind of effect. So if you go to set position, you should see the mutex that I'm using. It's a lock, then mutex on lock. That's happening for other things, like the rotation, for instance, also has the same thing, and other general methods. There's also a method for picking the direction of movement, which check available position in maze, which will randomly pick a direction for the movement. Then it will try to find the closest block to the character that is in the line of the direction. For instance, if direction is 0, then which means it's just on the positive x, right? So it will just check for the blocks that are on the positive x. Then find the closest blocks on the positive x and return its position to an offset position to the thread that does the movements. And that's it. For more information, contact Daniel Macklin or Felipe Bellini at Fanshawe College. Thank you.